Hi, welcome to Kitchen Matters. I'm Camille, and today we're using caramel to explore the science of your kitchen. Caramel is that same sweet that you use to drizzle as a sauce over your ice cream or as a chewy candy that you can unwrap from a wrapper. The difference between these things is the amount of water contained in the caramel when you cook it. Both of these can be made with the same ingredients. So today we're going to be looking at how to use material science to control these properties of your candy. If you've ever made caramel before, you'll know that there are a few simple ingredients. Caramel usually starts with sugar, but it also contains a few other things like butter or heavy cream, and sometimes it even has things like corn syrup in it. The reason for this is that the main component of caramel that we'll be talking about today is the sugar, which is made up of building blocks or molecules called sucrose. Usually these want to fit together like Legos and build a crystal structure, but if we want a smooth, chewy caramel, we actually want the solid to stay amorphous or not put together in a particular pattern. To do that, things like butter and heavy cream, which have a lot of fat in them, act like stuffing Play-Doh between your Lego blocks and keep them from fitting together. This basically keeps your caramel from turning into crystals. The light corn syrup that some recipes also include in your caramel recipe also helps to keep your caramel from turning into a gritty crystal structure. This is because it has different types of sugar building blocks or molecules as the sucrose atoms in your table sugar. Because they don't fit together in the same structure that the sucrose building blocks want to make, this can also help keep the crystal structures from forming. In caramel, we are melting this sugar and then we are cooking it until it goes through a process called caramelization, where it turns brown and takes on all those caramely flavors that you're used to tasting. After you've added your liquids like your cream and your butter, these serve the purpose of keeping the caramel from crystallizing and also contain the water that will be keeping our caramel chewy. We don't want to add them until after the sugar is done caramelizing and turning brown and delicious, because the reaction that causes the caramelization happens at a much higher temperature than the reaction that causes the milk solids in butter and cream to burn. We don't want to burn any parts of our caramel, so we'll be adding them after the caramelization is done. You want to control how hard your caramel is going to turn out, so you can stop very soon after adding these, leaving a lot of water in your mixture. This makes something like a caramel sauce, which is very runny and good for pouring. You can also cook it for much longer. More water will evaporate, and you'll get a much stiffer caramel, like the chewy ones that you unwrap in a store, or even hard caramel if you want something crunchy. The way that this is controlled is through measuring the temperature. The reason you can measure the temperature of your cooking caramel in order to tell how much water is left in it is because we're using the fact that when a liquid is boiling, it's going to stay at its boiling temperature. We know that water by itself will always boil at 100 degrees Celsius or 212 degrees Fahrenheit. But you might be wondering, wait a second, how can the temperature of our caramel be changing if we're keeping it boiling the entire time? Well, adding something like sugar or the sucrose building blocks from your table sugar can actually change the phase transition temperatures of materials. Material scientists keep track of the way the temperatures at which phase transitions happen using things called phase diagrams. You can see on our phase diagram for our sucrose sugar building blocks and water mixture, the vertical axis, top to bottom, shows the temperature of phase transitions, while the horizontal axis, left to right, shows how much of one material is mixed into the other. You'll also see at higher temperatures on the dotted line, we have a graph of the boiling point, or where the mixture of sugar and water starts boiling. You'll notice that on the far left, at very low concentrations of sugar, or where the mixture is mostly water, it's showing that the boiling point is around 100 degrees Celsius or 212 degrees Fahrenheit, about what we'd expect for boiling water. But as you get higher and higher amounts of sugar in your solution, you'll see that over to the right, the boiling point actually increases. And you can see that how much it increases depends on how much sugar there is. So we can use the temperature of our caramel with the liquids in it to tell how much water is left and how much has already evaporated. People have done a lot of work figuring out which temperatures of sugar and how much water in that solution corresponds to the textures of caramel that you want to be tasting. So let's get started making some caramel. We'll measure out the sugar first into a pan. We're measuring out 200 grams of sugar and putting them over medium heat. This sugar by itself is going to first melt and then caramelize, but this process will happen quite fast on a hot burner. So make sure that you're keeping an eye on it and stirring it regularly, even if your sugar looks pretty dry for the first few minutes. Once we have our sugar caramelized in a beautiful golden brown color, that's my favorite, we're going to first be adding our 6 tablespoons of butter. You want to keep stirring this constantly while you add your light corn syrup and your heavy cream. This is the point where we're going to be putting in our candy thermometer. Now that we've added the candy thermometer, we're going to see our caramel with liquids added go through several different stages. These are all named for the different textures of caramel or other sugar-based candies that they'll make, and they can be indicated by certain temperatures on your thermometer. We'll be looking at several of them as we cook our way through them. When you first add your liquid ingredients, you'll probably see temperatures somewhere around 106 to 112 degrees Celsius. This is known as the thread stage of sugar cooking, and this is the texture that's usually used for things like caramel sauces. Another way to test the firmness of your caramel is to drop a small sample of your mixture into a glass of very cold water. This cools down that amount of caramel very fast, so you can see the texture or performance of your candy as it would be once it's cooled down to the temperature that you want to eat it at. It's usually around room temperature. So the names of the stages that we're going to be talking about are actually named after the behavior of your caramel as it's dropped into a glass of water. The thread stage is named for the way that the syrup forms loose threads in a cold glass of water. As we keep cooking the caramel, we'll be removing water through evaporation as the water turns into steam and leaves the pot. This means that the percent of sucrose in our caramel is going to increase. We'll be moving right along the dotted line on our phase diagram, and as you can see, this also increases the temperature of the boiling point. This is the reason that we'll see the temperature increase on our candy thermometer as we keep boiling our caramel and removing water. Because the increase in temperature happens because we're removing water, we can use the temperature change to know exactly how much water is left in our caramel, and therefore how hard the caramel is going to be when it cools. The next stage that we'll be getting to is known as the soft ball stage. The caramel at this stage dropped into a glass of cold water will form into a soft ball. This is a good texture for things like caramels that are soft, and also things for covering cakes like fondant that you want to roll out and treat like a dough. At this point, you may begin to notice a little bit of browning in your caramel color. Since we know that caramelization happens at a much higher temperature that you've currently reached, high enough to burn some of your other ingredients, this actually isn't caramelization happening. The reaction that's darkening your caramel now is the Maillard reaction, which is toasting some of the milk solids in your butter and heavy cream. They're not burning yet, but you might notice your caramel get darker as we move into some of the harder caramel stages. The next stage of cooking caramel is the firm ball stage, and as you might have guessed by this point, it is also named for the fact that caramel that's dropped in water at this stage forms a firm ball. You can squish it between your fingers, but it will also hold its shape a little bit if you leave it where it is. The hard ball stage is the stage, again, as you may have guessed, where syrup in a glass of cold water forms a hard, sticky ball. This ball will hold its shape, and this stage is often used for things like firm caramels, nougat, and making toffees. The next stage is one of the stages known as a crack stage. This is when the caramel stops making balls and starts making threads again when dropped in water, but this time where caramel will actually break at room temperature instead of being soft and bendable. The first of these stages is known as the soft crack stage. You can see that this forms strands that are still a little bit bendy but mostly firm and will break. At the hard crack stage, we get a brittle type of sugar syrup or caramel. This is something that you would use for breaking into caramel shards. This is the last stage you want to bring your caramel to for any kind of uses for eating as candy. Past this stage, you'll probably start seeing some burning of those same milk solids that were toasting previously. As you can see from this characterization of our final caramel performance, whether it's for a soft sauce or for a firm caramel candy, we were able to use the processing approach, how much we cooked the caramel, to control its properties and make it more delicious for whatever our culinary pursuits were. And if you make something creative out of your caramel skills, please feel free to send us an email or pictures to let us know how you're using your new culinary science skills.